Okay, ladies, gentlemen, we are into half-angle formulas. We mentioned half-angle formulas briefly at the end of the previous video. Basically, half-angle formulas are ways to figure out exact cosine and sine and also tangent values for special angles that we know. For instance, suppose that you wanted to, suppose that you knew that the sine of 45 degrees is the square root of 2 over 2. And you wanted to figure out what the sine of 22.5 degrees is. Well, you could go ahead and plug right into here the 45. 45 divided by 2 is 22.5. And this will help us figure out the value of sine of 22.5 degrees. And that, again, will be an exact answer, which is more accurate than any decimal answer on a calculator. So let's go ahead and see how these formulas here work. By the way, before we move on, one thing I want to mention is this. If we look at this formula for a moment, here we have the variable x. You can take any formula like this and make your x into a y, or theta, just so you're aware. All right, let's go ahead and begin with an example of using a half-angle formula. So here it says, using a reference triangle, find cosine of theta over 2 if these conditions are true. Because they mention reference triangle, let's go ahead and draw a picture with a reference triangle. And it's in quadrant 1, so we have this part of our bow tie. There's the angle theta. They say cosine is 5 over 13, so that's adjacent over hypotenuse. Adjacent here 5. Hypotenuse 13. And usually our next step is to figure out the third side of the triangle. However, in this problem, believe it or not, we won't need the third side. Why? Well, it has to do with the information that they gave us. Look at the original formula up here. To get cosine of theta over 2, and notice I called that theta here, we're only going to need cosine of theta, and that's what we already have. They don't ask for a sine theta or a tan theta in the formula up here. And because they don't ask for those, we'll leave our diagram that way. Now, let's go ahead and plug right into our formula and see what's going to happen. So we'll begin by copying down the formula first. Next step, what do? Well, we know that cosine theta is 5 over 13, and this is cosine theta right here. So we're just going to replace this cosine theta with 5/13. And that gives us this. Now the next step. Let's go ahead and clean this up. One thing we know is that if we have an ugly looking fraction like this, and this fraction's not pretty, we can put parentheses around the entire numerator and around the entire denominator. And let's go ahead and add these together first. We'll need a common denominator, so we'll put this over 1. And the common denominator is going to be 13, so we'll multiply both the numerator and the denominator by 13. So let's see what this becomes next. I'm going to need to move my paper up there. Boy, this is, just so you're aware, for those people that know me, this is an extremely challenging kind of thing to do, to keep everything in its place and make sure that I've got the paper even in the right spot. And I know often I don't. Let's go ahead and add these together. So in the numerator, when we combine those, we're going to get 13 plus 5, 18. Denominator stays the same, all over 2. All right, let's go ahead and clean this up. This is a fraction. We'll put this as a fraction, writing it over 1. And anytime you have a fraction divided by a fraction, what do? Multiply by the reciprocal. So we're going to go ahead and write this as 18 over 13 times 1/2. Next step, because it's multiplying fractions, we can cancel first. And when we do that, we're going to end up next here getting 9 times 1, 9 in the numerator. 13 times 1, 13 in the denominator. Now, something that you may or may not remember ever learning is this. Whenever you're taking the square root of a fraction, you can actually split up the big square root into 2 smaller square roots. And when we do that, we're going to end up writing it this way, square root of 9 over square root of 13. And now the square root of 9 we can simplify, with 9 being a perfect square. That'll be 3 over square root of 13. And for our purposes, we can leave our answer this way. For those students that rationalize, you're going to get 3 square root of 13 over 13, which is also good. Now, the final step is to figure out if this is supposed to be a positive or a negative sign. How do we figure out which sign we're going to keep? Well, to figure that out, basically what we need to do is we need to figure out which quadrant this angle is in. Which quadrant is theta over 2 in? Well, when we drew our angle theta, we knew that theta is in quadrant 1. There's our angle theta right here. It's in quadrant number 1. How big does theta look? I would just estimate this theta right here, and my picture is terrible because 5 should be a whole lot shorter than 13. I would say that just the way I've got it drawn, maybe this angle is 30 degrees. It won't be. It'll be different. Now, when we take that 30 and we split it into 2, 30 becomes 15. Well, 15 is still in the first quadrant. Everything's positive in the first quadrant, and so our answer will be positive. All right, so that's how you figure out the sign. Let's go ahead and write the steps for figuring out the sign. We'll call these the sign steps. What we'll do is choose any angle in the quadrant. And here we had quadrant number 1, and so I chose 30 degrees. Next step, divide by 2. So divide the angle by 2 to see which quadrant the smaller angle is in. And then we use all students take calculus. So let me go ahead and move that up there so you can copy that down. Pause it, copy it down. After you get that copy down, I want you to try number 2 on your own, and then we'll go through that. All right, let's take a look at problem number 2. We'll do number 2 similarly to number 1. And so I'm going to go ahead. I don't have a whole lot of space right here, unfortunately. So I'm going to go ahead and just draw the diagram down here for problem number 2. For number 2, our theta is in quadrant 2. So I'm going to go ahead and just draw that part of the bow tie. Here's our angle theta. Next, cosine is -4 over 5, so that's going to be adjacent over hypotenuse. And now we can, like in the previous problem, plug right into our formula. So when we plug into our formula, which is right above here, we're going to get 1 plus our cosine, which is -4/5. All over 2. And again, what we want to do is clean this up like we did above. And so hopefully you convert it to a common denominator. Put this over 1 and multiply through by 5 this time. So when we do that, be the square root of 5 over 5 plus -4 over 5. all over 2. Next step, we're going to combine these together, so we're going to get 1 over 5 in the numerator, divided by 2. And we'll go ahead and do what we did before. Put this over 1 and multiply by the reciprocal. So plus or minus square root of 1/5 times 1/2, plus or minus square root of 1/10. Split it apart, plus or minus square root of 1 over square root of 10. Square root of 1 is 1, so we're going to get plus or minus 1 over square root of 10. Last step. It says choose any angle in quadrant. So what would be an angle in quadrant number 2? As I look right here, I'm going to choose 140 degrees. Next, divide that number by 2 to see which quadrant the smaller angle is in. So I'm going to go ahead and divide 140 by 2. And if I divide that by 2, I'm going to get 70. Now, 70 puts me back into quadrant number 1. Everything's positive in quadrant number 1. So we can get rid of the negative, and there's our answer. If you rationalize and write it as positive square root of 10 over 10, that's also fine. All right, ladies and gentlemen, now you're ready to start up the homework. Do your best.